let's start by going ahead and just getting the obvious one out of the way. You could just do it implicitly, where we just go ahead and we take the derivative of the left side and the derivative of the right side, and then we could solve for y prime from there. That is fine. That's kind of the default way, because that's how it's presented. But there are, of course, many other ways that you can go about it. All right, now thinking about other methods, let's say that you're sitting there and you're feeling kind of stuck on what else can you do. Let me give you a couple pointers. Is there a way that you could get rid of this natural log out of the left-hand side? If there is, try doing that as a technique. Alternatively, is there a way that you could try getting rid of the sine out of this side? If so, check that out as an alternative technique. Yep, so let's take a look at a few of those. Like, if I want to be able to get rid of this natural log here, I can put it into exponential form, which means that then I would turn it into e to the power of sine of x equals y. And then I could find the derivative from there. Notice we wouldn't even need implicit differentiation there, just some chain rule. Okay, how about getting rid of the sine? Can we get rid of the sine out of that side? What would I have to do to both sides in that case? Yeah, we could do inverse sine there. So there you could do like inverse sine of natural log of y equals x. You could do it from there. Okay, these are kind of maybe the first obvious ones, but there are, of course, many other options. So one other option that I saw just as I was walking around is I saw where we divided both sides by natural log of y, and so it became 1 equals sine of x over natural log of y. You could do it that way, or you could even do it the other way. You could also do 1 equals the natural log of y over sine of x and find the derivative of that. By the way, interesting to note that whether the sine or the natural log is on top or the bottom in this case, notice we should end up with the same derivative. An interesting idea there. Yeah, building off of that one, I could take either of these and change them from quotient rule into product rule. So I could turn it into like sine of x times natural log of y to the power of -1. And the same kind of thing with this one, of course, as well. And then it becomes a product rule instead of a quotient rule. Nice. Of course, that's by dividing both sides by the other side, right? You didn't have to divide both sides by it. You could even subtract from both sides, like 0 equals sine of x minus natural log of y. Or, of course, you could move it to the other side as well. You could do natural log of y minus sine of x equals 0. And you could be finding the derivative of that. And these are all kind of the straightforward ways. But there's even all sorts of other crazy ideas out there. Just so that you know, not that you necessarily would need to come up with these, but like we talked about getting rid of the sine here by doing inverse sine of both sides. But I could get rid of the sine by other ways. If I wanted to be really kind of crazy about this and turn it into something that looks really wonky, like I could turn it into natural log of y equals the square root of 1 minus cosine squared of x. And so lots of ideas, and we could get into all sorts of other crazy things like this, like we could redefine sine in terms of like tangent or something like that. I mean, there's all sorts of stuff that we could do along the way. And so you can see there's tons of manipulation that you could be doing here. Oftentimes I notice, though, that we tend to feel resistant to looking for some of these other methods, right? But a lot of the solution methods that exist, they exist because people played with it and they figured out, oh, if I rewrite it like this, I can figure it out. Like, remember when we figured out and actually find the derivation of inverse sine's derivative? We had to do some funky substitution there. We had to actually get rid of the cosine y that we had in there. We had to replace it with the square root, kind of like we just did on this part, that sort of a thing. We find those things by actually playing with the math. And yes, you can play with math. It's okay. And as a side note, we didn't even start listing in here all the other resources we could go to, right? Because those would always be there, like resources on the internet, people you could ask, stuff like that. So just remember, there are so many different ways you can approach these. So that means that, like, if you're looking at a problem like this, and the other problems that we will be working with going forward, if you find yourself getting stumped, ask yourself what else you could do. Because there's often a way that if you don't remember one method, I bet you could figure it out using the other method. So just keep that in mind as you go forward. But today we are going to be doing a little bit more practice with our derivatives, of course. So please go ahead and write down and then find this derivative. All right, as we are finding this derivative, of course, it's natural log, so we're going to do 1 over my inner function. And notice my inner function here, it's that cube root. And so the cube root, the whole thing, just as it was before, stays on the bottom. So it's going to be cube root of the 6x plus 7. All right, but then we have to multiply that by the derivative of that cube root. And so if I'm just looking at this cube root here, I'm now finding the derivative of that, which notice again is going to mean another level of chain rule. So this is another one of those where we have chain rule within chain rule. Now, in order to find the derivative of the cube root, please remember that cube root is going to be the same thing as 6x plus 7 to the power of 1/3. And so I'm going to take the 1/3 out front. Let's actually just go ahead and put this into our problem. So it's going to be the 1/3 out front. The same stuff on the inside, 6x plus 7. And that's going to be to the power of what in our derivative here? Yep, negative 2/3. Every now and then I see somebody who wants to say like negative 1/3 or something like that, because we get so used to how 1/2 minus 1 gives us negative 1/2. We tend to think of it as being the same fraction, but of course it's not. We're actually subtracting 1 from it. All right, and then while this is correct so far, we're not totally done yet. Remember, we were using chain rule within chain rule, so I still haven't done the derivative of that innermost function. The derivative of 6x plus 7 is just 6. And then from there, clean it up. And yes, in this particular case, I would like you to please clean it up as much as you possibly can. There's actually quite a bit of simplifying that you can do here. All right, so like on my next step, I'm going to just try to put everything into the same format. I'm going to go ahead and stick with all the fractions here. So it's going to be 1 over the cube root of 6x plus 7. All right, then my other one, that is a big old fraction over here, where that negative 2/3 power means that I'm going to have the cube root down here of my 6x plus 7 squared. And then the 1/3 times 6, that would be 2. Not 1 over 2, but 2. So that means there's a 2 on the top. All right. But now notice that the stuff inside of those two cube roots is the same. I have this 6x plus 7 to the power of 1/3 in the bottom of the first one. And I have the 6x plus 7 to the power of 2/3 in the denominator of the second fraction. If I put those together and multiply them together, what do I do with the exponents? We add them, because the bases are the same. They're both 6x plus 7, so we can get away with that. And if I add 1/3 and 2/3, that just equals 1. Which means that this thing really does get a whole lot simpler, because when I multiply them out, I just end up with 2 over 6x plus 7. And that's it. All right, now if you've gotten to this point, we're getting there, but we aren't quite there yet. Because, you know, when we do derivative of like natural log, this is what we'd be looking at, because it's just 1 over our inner function. So 1 over our inner function times the derivative of that inner function. The derivative of 2 plus sine, yes, is going to be cosine. All right, But this one's missing something. Because this is just log. It's not natural log. What's the derivative of just log of x? Yep, it's going to be 1 over x natural log of the base. What is the base in this case? 10. And so it's going to be 1 over x natural log of 10. And so that means that I got to put the natural log of 10 in here. Okay, so then natural log of 10. Great, so is that one good now? I hope you're thinking not quite. Right now, this natural log is only being multiplied by the sign. But it's not supposed to just be times the sign. It's supposed to be times the entire thing. And so we need to have parentheses around the 2 plus sine x to show that the natural log is multiplying by that whole inner function. That's a little tricky one. And that's the sort of thing that, especially on things like tests, trips people up. We forget about that little bit of detail about the parentheses, but of course it makes all the difference in the world about what that function actually does. Now, if you want to be worrying about cleaning it up, there's not a ton of cleanup we can do here. We can put the cosine of x on the top of our fraction and maybe write our constant on the bottom first. But otherwise, it's pretty much the same thing. There's no real simplification we can do past that in this case. All right, so when we start taking the derivative of this, remember we're just going to take the derivative of each term individually. So first up, derivative of 3y is just going to be 3y prime. All right, then we go on to the x squared. Well, that's just actually a nice simple derivative. Derivative of x squared is 2x. All right, then we go on to find the derivative of this y natural log of x. Which rule am I going to need to find the derivative of y natural log of x? Yep, notice this is y times natural log of x. So yes, it's going to be product rule here. All right, so product rule, that means original times the derivative. So the derivative of natural log is 1 over x. Then that's going to be plus derivative times original. Derivative of y is y prime. And that's going to be times the original, natural log of x, equals 2. Great. What? Ah, very good. You may recall that I mentioned there were some potential pitfalls in this one. One of the big mistakes that I'll see people make, especially on tests, because tests are more stressful, things like that, is that we'll forget to actually take the derivative of the constant on the other side. That's one of the biggest mistakes I see when people are struggling on these, is we forget to actually change that 2 into a 0. So remember that little piece along the way. All right, from here, you're solving it for y prime. All right, so I moved all the y primes to the left, all the non-y primes to the right side. Now we can go ahead and factor out the y prime from both terms on the left. And then finally, you can then divide both sides by whatever is multiplied by the y prime. So I'm going to divide both sides by that whole thing. All right, and here is then our final answer.